Welcome back to Exploring Linux with Muntasir Mustafa. This time we're going to be looking at the booting process of Linux computers. Alright, so let's first get an overview of this topic. So booting is the process by which the computer starts itself up. It does this in three main steps. First, it finds and runs the bootstrapping code. Next, it uses the bootstrapping code to select and find your OS kernel. It loads the kernel into memory and then executes that. And then finally, the kernel itself will execute the startup scripts in daemons like SystemD, and those daemons does the initialization, or also known as the preparation tasks, like checking and mounting your disks, setting your time zones, and starting other daemons so that your computer can be made available to the user. As an administrator, you can't control these steps of booting directly, but you can change how the system boots by passing arguments to the bootloader, or by changing the configs for the startup files. Starting from the moment that you press the on button, the computer is hardwired to automatically execute from a chip, called the ROM, or read-only memory. This ROM stores the boot code inside. The ROM's code knows about all the devices that live on the motherboard, like the USB controllers, temperature sensors, and more. By pressing a special key that the system usually displays when it's just turned on, you can do hardware configuration on these devices, or hide or even disable them. After the ROM finds your hardware and your disks, it needs to find the next stage of the bootstrapping code. You can select where it finds this from. To boot from a specific drive, you must set that drive as a highest priority disk, and choose hard disk as your boot medium. The next step is your bootloader. Your bootloader will usually be something called GRUB, or Grand Universal Bootloader. The bootloader's main job is to load the chosen OS kernel. The bootloader's UI can let you select from several OSs if you have them. It also has the job of sending configuration arguments to the kernel. For instance, adding the argument single will boot the kernel into single user mode. You can add these configs using the bootloader's UI, or you can put the args into the bootloader's configuration to use the argument every time it turns on. As for grub specifics, you can edit grub's configs using the config file called grub.cfg. Grub also has its own command line that allows you to edit these config entries at boot time using commands. If you press C while on the grub screen, this will be opened. After this stage, the OS kernel will be loaded, and that will load up the startup scripts and system daemons. The final stage in the boot process is executing startup scripts. Modern systems use something called SystemD to do this. So, what is SystemD? SystemD performs a number of crucial system tasks, but its main job is ensuring that the system is running the right services and daemons at any point in time. To know which services and daemons are appropriate, SystemD checks your system's current mode. Different modes start and stop different services and daemons, and SystemD facilitates these transitions. Some different important modes include single user mode, which has minimal file systems mounted, no network services, and a root shell running on the console, which is used when you need to fix issues in the system. Multi-user mode, which has all the usual file systems mounted, and network services are started. And server mode, which is similar to multi-user, but doesn't have any GUI, which is used for servers mainly. The next thing to talk about is the systemctl command. Systemctl allows you to manage systemd, and has many subcommands that you can use to do this. Let's go over some important systemctl subcommands you might need to use. The first of which is systemctl isolate, which allows you to change the system's mode. Some examples of this that are commonly used are systemctl isolate rescue target, which puts it into single user mode, which we discussed earlier. Systemctl isolate multi-user target, which is actually the server mode, which means that it has all the mounted systems but no GUI. And systemctl isolate graphical target, which is multi-user with GUI. When you transition modes or first boot the machine, systemd consults unit files, which are records for each service, device, or any other kind of thing managed by systemd. Unit files contain information, for example, for service files on where to find the executable for the service, how to start it and stop it, and what dependencies it has on other processes. These dependencies are important because they tell SystemD not to do things like start a service that depends on the network before actually starting the network. As you can imagine, a system admin may have to fix issues stemming from dependency problems. To fix these dependency issues, you can create override files that can edit the dependencies or the execution order of the unit files to make sure that everything starts up in the correct order. Some other important systemctl commands include systemctl enable, which will mean that the unit that you choose will automatically activate at boot on its own, or systemctl disable, which will do the opposite, and it will prevent it from starting automatically, but you can still start it manually. Systemctl status, which will tell you what state it's in, for example, enabled or disabled from the previous examples. Systemctl start, which starts a unit immediately, and systemctl stop, which is the opposite. So that's all for today's video. Please leave any questions in the comments below, and I'll be back real soon with the next one.